Hey everyone, so today I am going to go over the interpretation of data, organizing and representing data. So my name is Heather McPherson and I hope this gives you a little bit better insight on interpreting using graphs and tables and different ways of seeing data that's given to us on a daily. So here we are. How can you represent the following data to identify the typical score? Here we're given just a bunch of numbers. So look at these scores and you can see that they range from 43 to 96. But what is the typical score? And how can we represent it to show it a little more? So we can use dot plots and we can use stem and leaves. Now I'm going to go over a little bit more of those and just on the next slide. So I'm sorry, I just got over a cough, so bear with me. I am going to show a dot plot, and here we have just a line. Now I started with I did my integers in fives. So I started with 40 and I end with 100. And as you can see, these dots right here all represent the different scores. So 43 only had one person that scored it, 44 had one. We go down the line and you see that 75 has two. So that represents that two people scored a 75, along with two people scored an 80 and so on. And by looking at this, you can see the typical scores range about 80 to 88, even because there's more people, two people each that scored these scores. Now, not only is a dot plot easy to read, but so is a stem and leaf. So here we have a stem and leaf table, and it shows the same data as the dot plot. Remember that the stem is the tens digit, so the 40, 50, 60, 70, 80, 90. And the leaf is the ones digit, so we have the 43, 44. And once you look at this table, you can also see that the main scores are again in the 80s. So 80, 81, 84, 85, 87, 88. I like looking at a stem and leaf because it just pulls me right away to what the data is and where it stands. You can use both of these when you're given a bunch of scores or different types of data to help visual learners to see what they're looking for, like we were looking for the typical score. So next we are going to look at frequency tables and histograms. And how do you create a frequency table and histogram? Well, here we're given all of these numbers. Again, lots of numbers. And these represent the heights of 30 girls. On this next slide, I'm going to go ahead and show you what the table and the histogram would look like. And then we're going to flip over to Excel and I'm going to go over how we got that table and that histogram. So here we have the table, and it's the height and the frequency, so all the heights 57 through 73. And with this information in this table, we can create our histogram, which is going to look like this. Again, gives you 57 to 73 and how often or the frequency of each one. Looking at the histogram, you can see that 65 was the most frequent height out of the 30 girls that were studied. So here we go. I'm going to end this for a minute and we're going to go ahead and open Excel. And I already went through in column A and wrote down all the heights just to save a little bit of time. So with this information already inputted, now we have to create a bins column. So here you're going to put in all of the heights, so 57 to 73. And you're going to include even the ones that we didn't use. So let me input all of these. And while you're doing that, know that this is just helping to get the frequency. And again, even though we didn't use some of these heights, it's easier to just add all the numbers so that we have correct data input. 72, 73. All right, so once we have this all completed, I'm going to highlight this column D, and I'm going to highlight it from 2 all the way to 18. So it's going to measure with the bins column. And here we're going to put in an equation. Now, I did this I don't know how many times and completely forgot the equal sign, so it never added up right. Make sure when you are putting in an equation in Excel that you remember to put the equal sign. So our equation is equal frequency, and you are going to put the data, so that is column A, and the bins, which is column C. So you're going to go from 57, so it's A2, and scroll all the way down to 31. So put a colon and put A31. That's your first set of data. Now you're going to put the bins data. And you see that didn't go all the way to 31. So you're still going to do the 2. So it'll be C2 colon C18 because it only went to row 18. Close that parenthesis, but do not hit enter because then your data will not create. Once you have this inputted, you're going to hit Control Shift and then enter. And what it does is it populates your frequencies without you having to go back through and see how many times it was 57, 58, 59. Works out so much better. So while this is still highlighted, you're going to hit your Data tab up here and hit Data Analysis. Now you're given a lot of different things that you can choose from, but what we're looking for is a histogram. So make sure to click that and hit OK. Now here you are going to put in your input range and your bin range. And again, it's the same thing that we just put up here in the equation. So it's A2 colon A31. And the bins range is C2 colon C18. Before you hit OK, make sure that the labels box is checked, the new worksheet ply is marked, and the chart output is checked. Once you've realized that all of that is done, go ahead and hit OK. And what it does is it creates your table. Now, you take a look at this and you see that your 57 is missing. So what I did, again, I apologize for the cough, is I went back through, and where this column 18 is, we don't need a more. So you just delete that whole row, and you start here and re-input your data. So 73 has 1, 72 has 0, and go up all the way till you get all the data re-put in. And it can get a little confusing, so just take your time on this part so that you make sure that you have all of your data correct and that you're not missing anything. I haven't figured out why it is skipping my 57, but this is the easiest way that I found to fix that problem for now. So maybe I can figure out what's going on with Excel. Even with this little hiccup, it is still so much easier to use Excel to get my information that I need to create my histogram. So here we have 58 is 3 and 57 is 1. Go ahead and change this to where it says heights. So your table is now heights and frequencies, and your histogram is height and frequency. So change this 57 just to title your histogram here. And this shows again your frequencies and your heights. Again, so much easier to use Excel than to try and draw this out and your table out. Use Excel. It is amazing. So now we're going to go back to this PowerPoint, and we've already seen the table again and the histogram. But now we want to construct a pie chart, and we're going to use Excel again. Again, I'm sorry. So the data that we're given here is Miss Smithson's, what she spends her money on in a year. Taxes, insurance, rent, all of that. We're also given that her yearly income is $66,000 a year. And in order to figure out how to create this pie chart, we would need to divide what she spent by how much she made in the year, then multiply that by 100 to get the percentage, because all pie charts need to be in percentages. So to do that, you have 20,000 divided by 66,000 times 100 equals 30.3%. You're going to do that for every one of her expenses. And here we have the table already done and already in the percentages. Now, we can see taxes is 30.33 or 30.3%, rent is 19.4%, and so on. So this makes it a whole lot easier to create our pie chart. And again, we are going to go out of here and go to Excel. Scroll down a little, and we are going to input the table right here. So I'm going to quickly type out category and percentage. Category is taxes, rent, clothes, insurance, so on, so on. And again, this makes it so much easier when you are trying to create pie charts and bar graphs and everything else. It looks like it's a little time consuming, but I promise you it's not. Now make sure that you put the percent sign. And as you can see, it is making my percents into, instead of tens, into hundreds place. I'm going to show you how to fix that part as well once we get here. So I'm putting in all this data that we've just figured out on how to get the percentages. And once I get this input done, I'm going to right click, and you see this tab right here where it says decrease decimal. We're just going to go through and decrease the decimal by right clicking all of these. And now we have it with just the tens. Go ahead and highlight the whole chart. You're going to go here, I'm going to make it bigger. Go to home, and you're going to make all borders so that it makes it into a table. While it's still highlighted, go ahead and hit insert. You see there's a little pie graph icon here. Go ahead and click that, and it creates your pie chart for you. Now, this isn't the only type of pie chart you can use. You can change it to look however you want it to look. It can give you the percentages inside the pie graph, or you can choose whichever one works best for you. So as you can see, I chose this one right here that not only gives you the percentages inside of the pie chart, but it also labels inside the pie chart as well as outside the pie chart. I like this one better because I can just look at it and I know exactly just by the pie chart itself what the taxes are, percent is, the miscellaneous percent, and everything. But that's another way of using Excel on for a pie chart. And we're going to go now. We just calculated the percentages for a pie chart, but how do we calculate the angle measures for a pie chart? Here, again, we're given the percentages, but we want to know what the angles are. So you see these different sizes of this pie chart. We want to know the angle of each one. So first, we have to change the percentages into decimals. So for 33%, you would have 0.33, and you have to multiply it by 360 degrees. Why do you have to multiply it by 360 degrees? Because a circle equals 360 degrees. So that little piece, that 33% of income, is just a part of the 360 degree circle. So multiply each of them by 360 degrees. In this example, you get 118.8 degrees. And that is the correct answer, but we want to round up. So since 8 is higher than 5, you're going to go ahead and round that to 119 degrees. And go ahead and do that for the 4%, 11%, 22%, and 30%. So here we have all of our angles. We've calculated from decimals, multiplied it by 360 degrees, rounded however we needed to round, and we've got all of our angles for the expenses. I like to double check my work. When you have your percentages, they're going to equal 100%. Well, your angles, when added together, should equal 360 degrees because that's the total of a circle. So go ahead and add them all together, and they are going to equal 360 degrees. So you know that your calculations are correct when it equals 360. And there's our pie chart. Again, you can see that this 33% is just a tad bit more of an angle, which is a 119-degree angle versus this 108-degree angle. May not look like a lot more, but you can see this dark blue is just a tad bit bigger. I'll move my little cursor for a minute, than this light blue. Now, the following pictograph, is it an accurate representation or not? Well, by just looking at it, the pictograph doesn't really look like it's represented accurately. So I would have to say no, it's not represented accurately. But why is it not represented accurately, you wonder? Well, when you look at it, it appears to have more than doubled. But is that real? Is that true? First, you need to know the volume of the first house. And once we know the volume of the first house, which is length times width times height, we can figure out the dimensions of the second house. So the dimensions of the second house are going to be 2 length times 2 width times 2 height. Knowing this, we now need to factor out the coefficients. So you're going to have 2 times 2 times 2, which is 8, and it's going to be 8 times length times width times height. Therefore, the second house has 8 times the volume of the first house. So although it would be more helpful for them to print the actual asset value for each year on the front of each building, the pictographs themselves are still not going to be represented correctly. So the ratio of the volume of the large building to the volume of the small building is 8 times the volume of the first house. Now, how do you represent the data below using a table, a line graph, and a bar graph? Well, here we are given the population in millions and the years. And even though this is in itself a table, it's not one that we're used to reading. So what I did is I flipped it and I put the year in the left side corner or left column, and I put the population in millions in the right column. Once I have this data inputted, again, use Excel to make this table because then you can make any graph that you're looking for. So I input this data. While it's highlighted, I go ahead and click on a chart, and we're going to look at the line graph first. And it automatically puts in the information that's in the table, which again is amazing because sometimes when I draw out line graphs, my numbers are there, but it doesn't add up. It doesn't look correct to me. By looking at this as a visual learner too, you can see that as the years go on, that the population is steadily increasing. There's no straight line to say it plateaued, and there's no line going down where it says the population dropped. So that is very helpful when you're looking at line graphs and bar graphs, because as you can see in this bar graph, it's the same thing. Your bars are increasing in size, which means the populations are growing as the years go by. So I really do hope that I helped give you a little bit more insight on representing data using line graphs, bar graphs, histograms, and even tables. And I hope I let you in on a little secret about using Excel when creating these for your classrooms or anything like that. So have a good day. Thanks.